Hi guys, this is Devashish Sharma from Amity University, and I am going to present on machine learning. Here are the contents which we will be seeing in this presentation. The first one is introduction. These days, artificial intelligence is making great strides, and it is the most exciting branches to investigate and to learn from. Machine learning is a critical enabler, or we can say is a subset of artificial intelligence, which focuses mainly on learning of machine from their experience and making predictions based on gained experiences. It is a concept which allows the machine to learn from examples and experiences, and that too without being explicitly programmed. So instead of you writing the code, what you do is you feed the data to the generic algorithm, and the algorithm or machine builds the logic based on the given data. These programs or algorithms are designed in a way that they learn and improve over time when they are exposed to new data. Machine learning is everywhere. Today, machine learning methods are used to continually improve the personalization of specific technologies. Within an enterprise, unique algorithms and models are built to power everything from fraud detection and recommendation engines to medical image classification and aircraft scheduling. Its history. In the year 1950, the first machine learning algorithm was created. After that, Arthur Samuel developed a program for playing checkers in 1952. In 1957, the term perceptron was proposed by Rosenblatt. J.R. Quillen in 1986 came up with a study of decision trees, most notably the IT3 algorithm. In the 1980s, there were a sudden rise of interest in neural networks with the development of backpropagation. In the 90s, machine learning embraced the statistical approach to a large extent. It was during this time that support vector machines were introduced by VecNet and Cortex in 1995. The SVM was proposed near the 2000s, which was exploiting the knowledge of convex optimization, generalization, and kernels. Here are the some types of machine learning. The first one is supervised learning. It is a learning where model is trained with labeled datasets. The input output parameters are labeled or already being taught to the datasets. The datasets for training and validations are labeled in this sort of learning. Example are like regression, k nearest neighbor, support vector machine, and etc. The second one is unsupervised learning. It is the learning where model does not trained with labeled datasets. The algorithm has no correct answers and no teacher. Algorithms are left to their imagination to find and present an interesting structure in data without training of labeled datasets. It makes clusters based on the similarity of a given data. Examples are like k-means clustering, principal component analysis, probabilistic, etc. The last one is reinforcement learning. It takes direct inspiration from how people learn or absorb from the information or activities they encounter in their daily lives. It introduces a self improvement algorithm and learns in new situations using trial and error method. The action is taken by the agent and the environment transforms to a new state and gives the agent a reward or the encouragement. That reward can either be a good or reinforced or a negative or punishment or nothing at all based on the outcome. We can see the visual definition of the respective machine learnings. Now, neural network. Neural networks, also known artificial neural networks, reflect the functioning of the human brain, allowing computer programs to detect patterns and solve similar problems in the fields of artificial intelligence, machine learning, and deep learning. They consist of layer of nodes, which are made of input layers with one or more than one hidden layers and output layers. They depend upon training details to learn and improve their accuracy over time. However, if the algorithms are well designed, they are the omnipotent tools in the field of computer science and artificial intelligence, which allows us to decompose and collect data at high speed. Neural network can be classified into various types. The most frequent among them are first is multi-level neural networks. They consist of inserting hidden layer and outer layers. They contain sigmoid neurons as many real-world problems are based on nonlinear data. They are the basis for computer viewing, natural language processing, and other neural networks. Feed-forward neural network or MLPs with two or more layers have the greater processing power and can process non-linear patterns. Second is convolutional neural network. They reassemble multi-level neural networks, CNNRs, are made of an output layer, input layer, and a hidden layer with many convolutional layers, normalizing layers, and pooling layers. They are frequently employed in picture recognition, pattern recognition, and computer vision. These networks uses the principles from direct algebra, particularly matrix duplication, to identify patterns within an image. The last one is recurrent neural network. The feedback loops distinguish recurrent neural networks. These learning algorithms are generally used to create predictions about future outcomes using time series data such as stock market projections or sales forecasting. There are a good choice for applications like handwriting identification and voice recognition that require building up sequential representations of data over time. Long short term memory, that is LSTM units or gated recurrent units, can be added to an RNN to help it recall significant details while forgetting the unimportant ones. We can see the visual definitions of the respective neural networks. Now, future of machine learning. Machine learning has now used in various technologies from a Google suggestions, products, or Netflix recommendations to image and speech recognition, self-driving cars. It is a key component of artificial intelligence which are present in our daily lives day by day, and without machine learning, artificial intelligence is near to impossible. Here are some applications of machine learning. First one is quantum computing. Quantum computing allows multiple multi-state operations to be performed simultaneously, resulting in faster data processing. Google's quantum processor completed a task in 200 seconds that would have taken 10,000 years for the world's best supercomputer. Quantum machine learning has the abilities to improve data analysis and yield deeper insights. Second one is automated machine learning. It is automating the application of machine learning algorithms to real world operations. Automated machine learning streamlines is the process so that anyone, including businesses, may use advanced machine learning models and techniques without having expertise in the given field. Automated machine learning can automate various of development stages of machine learning model. They are data pre-processing, feature extraction, model deployment, monitoring, and many more. The last one is machine learning in healthcare. Massive amounts of data are generated in the healthcare industries. Machine learning approaches can make a big differences in terms of bettering predictions and treatments. The machine learning technique allows for the study of a broader range of variables based on studies, patient demographics, health records, and other data, perhaps leading to better illness predictions results. Machine learning techniques like natural language processing and image processing can aid in the conversion of data into the standard form. Now, I would like to end my presentation with a logical quote. You can have data without information, but you cannot have information without data, by Daniel Case Morin. Thank you.